Biometric data exchange has become an essential tool for forensic agencies worldwide. It allows for sharing crucial information in criminal investigations, aiding in the identification of suspects and the resolution of cases. In an increasingly globalized and connected world, cross-border biometric data exchange becomes essential to combat transnational crime effectively. However, this cross-border biometric data sharing comes with important challenges centered around security, privacy, trust, and collaboration between different forensic agencies. While legal and regulatory frameworks of European countries ensure that the exchange is conducted in a lawful and accountable manner, they demand different set of rules and guidelines for agencies to follow. In addition, there are challenges related to building trust among cross-border forensic agencies, addressing issues related to trustworthy participation in a data ecosystem that facilitates biometric data sharing and exchange, and enables data sovereignty, governance, and ownership. Data owners or providers are able to keep control of the data they own, and impose usage policies to others to whom they share their data. An emerging data-driven technology, called data spaces, can provide a data ecosystem that enables a secure, controlled, and trusted sharing of biometric data in cross-border scenarios among forensic agencies, facilitating the investigation process. This is the aim of the TENSOR Biometrics data space that relies on the data space technology to offer a data ecosystem where forensic agencies can share biometric data without disclosing sensitive information, and when strict terms and conditions are met. The TENSOR Biometrics data space is a trustworthy ecosystem for biometric data sharing and processing, and enables data sovereignty. Data providers maintain the control of their data, impose data usage policies on the data they own and share, and data consumers respect the data usage policies imposed by the providers. Emerging technologies such as homomorphic encryption, large-scale data indexing, and blockchain-enabled smart contracts are supported and enabled within the data space. In TENSOR, we aim to design and develop the first European biometrics data space, which relies on the International Data Spaces Association reference model. The progress made within the first year of the project contributed to the design of the biometrics data space architecture, the development of the supportive middleware that will be used for the registration and authentication of the users, and the development of the related service that will facilitate the conduct of biometric data searching within the biometrics catalog. Moreover, the identification and the definition of the endpoints that will be used by the emerging technologies such as blockchain-enabled smart contracts, homomorphic encryption, and large-scale data indexing within the data space was made. According to the IDSA reference architecture model, a data space aims to enable a trusted and controlled data ecosystem, where data sharing and exchange among organizations is orchestrated, ensuring data sovereignty, security, and interoperability. Moreover, according to this model, a data space doesn't prescribe specific data types or formats, but it provides a framework that supports the exchange of various types of data. In the context of TENSOR, and with respect to the scenario definition of use case 3, input data will be facial images of well-known data formats such as JPEG, PNG, etc. Similarly, the same holds for data output, which can be raw, encrypted and processed facial images. In use case scenario 3, a biometric data exchange between two forensic agencies of two different countries, Portugal and Moldova, takes place within the TENSOR Biometrics data space, aiming at the identification of a suspect and the resolution of the case. For simplicity, we refer to Ministério da Justiça of Portugal as Agency A, and to Inspectorato General Politia of Moldova as Agency B. The identification of a suspect by Agency A, using known methods, fails. Agency A has a facial image of the suspect and aims to investigate whether are records of this suspect in the databases of foreign agencies. Access on the databases, where biometric data are stored, is not allowed by third users or agencies. Search and comparison actions to identify possible matches cannot be conducted directly on the raw biometric data, but only on encrypted and indexed data under specific terms and conditions, and upon approval of the request. If similarity scores of the comparison indicate a possible match in the database of agency B, and when specific terms and conditions are met, data exchange occurs through a blockchain-enabled automated smart contract execution between the agencies, conforming to the settled usage control policies. The usage control policies are imposed by the data provider, which is agency B, and are fully respected by the data consumer, which is agency A. The following demo video aims to demonstrate a proof-of-concept scenario, presenting how a biometrics data space can be used by agencies for biometric data sharing. It is important to note that at the current state, the supporting technologies that will enable increased privacy and security mechanisms such as homomorphic encryption, large-scale biometric data indexing and smart contracts are under development, and cannot demonstrate the full capability of the biometrics data space. Therefore, for the purpose of the demonstration only, searching is conducted using soft biometrics by the registered user, and the matched image is retrieved and displayed in the monitor. The next steps require the integration of the aforementioned technologies within the data space, to allow for searching using the actual image of the suspect, which will be processed without disclosing or revealing any sensitive information. On the landing page of our platform, there is a login button positioned on the right-hand side. By scrolling down the page, one can access some fundamental information about the TENSOR project. Our project is focused on facilitating the secure exchange of biometric data. This is achieved through the use of cutting-edge IDS connectors. Each user is able to query and retrieve data via the designated consumer connector, which connects to a producer connector to transfer the desired data. In this demonstration, we will showcase two data transfer examples. Initially, we will connect to the connector A, the consumer, and retrieve data from the connector B, the producer. After logging in with the user credentials of connector A, a query is submitted for the term female. Connector B responds with a results record. The user can then drill down and display the associated media. For the second example, we log in with the user credentials of connector B, which retrieves data from connector A, the producer. After logging in, a query is submitted for the term smoker. Connector A responds with a list of results. By clicking on the Details button once more, the user can open the associated media,